Hi and good evening. My name is Devanand, son of Ravindran, and my matrix number is CE220129. And today I would like to present my part, which is the introduction session for assignment assignment 1 from group 5. And so this is the introduction, and RAM, which is known as random random access memory, which is a volatile memory which stores data temporarily once the power turn off from the computer. The data which is inside the RAM gets erased. So it's known as a primary memory too. And this the how does it operate is the operating system actively uses RAM and its applications that are necessary to execute a file or a program. Thus, it speeds up CPU processing by providing fast data instruction access. So that's the role of RAM, and it's just a short-term memory. It acts as a short-term memory where uh, it's like a human brain actually. Uh, there are different ways of keeping memory, like short-term memory and long-term memory. Likewise, in computers, there are like different ways in saving memory. There are cache memory, primary memory, and secondary memory. So, so this can get one of the advantages is it's fast in multitasking and faster in running applications since the data can be accessed more quickly. And next is the problem statement, where it involves the problem statement is focus on data manipulation, where it organize it makes the data more organized and easier to interpret. And this task involves the managing the transfer of the 26 uppercase letters of the English alphabet stored in a single memory location in program memory into SRAM starting at memory address 0 times 1000 to FFF. And students are provided with software tools specifically for the ARM Cortex M3, ISA, and KLU Vision software to accomplish this project. And to summarize the program copies, uh, to summarize this project, we use 0 times 100 00000 and corresponds to A, and it transfers to a new memory location and save it. And it uses the sequence of ASCII characters from one continuous block of memory to another, continuing until Z is reached. And to solve the issue, the problem given for this assignment, we will use Keil software to solve the complex issue of accessing data and memory. So Keil Vision software helps. So the micro Keil Vision helps us compile and debug the C++ code, the source code. So once the code is done, so when there's zero error, then you can start to debug it and then it will run. And it shows that the simulation is successful. And firstly, we need to create the flowchart to organize the memory access process. So this gives us the guidance to for coding development. And by leveraging Keil Vision, we streamline development, making it easy to handle data memory access effectively. So that's all for me. I would pass to my next member.
Hi, my name is Kaisara Syami binti Rosli. My numeric is DE220208. And now I will present about a flowchart. Firstly, when we want to run the program, start and the data address, the data address is equal to 100002FFE. Then the data address is registered to R2 and the data is load to R0. Then R3 is equal to 0. That means the counter start with 0. Then memory in R0 and data will in load to R1. Then R0 will plus 1 for the next data to load. Then R1 we plus with 20 because data we need the data that we want is need to plus with 20. Then store to R1. Then after that memory R1 the data that we have add will store to memory R2. Then memory R2 we plus with 1 to reload for the next address. Then R3 the counter we plus with 1, so we load go to the next address. So after we run, we need to know that the R3 is equal to 28 or 26 or not for the last location that we need to run. If not, we need to rerun back for the memory R1 with the memory R0, the data, the next data to R1 until we get the R3 counter to the 26. After that, we already get the 26 R3. We yes, and the end of the system. That's all from me. Thank you.
My name is Sharvina. So for the next part, I will be explaining about the coding using the Keel Microvision software. So this first three line represent the area for the code, and then this is main, and then the sixth line is to declare our data address, which is equals to 0x1000 to FFE. So this is our starting address of our memory, and then we need to load R2 equals to data address. So this address will be loaded into R2. So initially R2 will have this address, and then load R0 equals to data. So if we have this comma and equal, it means that it will not load the data, but it will load the address of the data. So these are the data, and all of these data will have its own memory address. So it will load its address into R0. All of these address into R0 one by one, and then we need to move R3 equals to 0 because R3 acts as a counter, and we need to initialize it to 0. And then L1 is represent loop, and then load a byte of data from R0 to R1. We need to move the content of the R0, which is this, into R1. So let's say, for example, 41, we want to move this 41 to R1, and then the address will the memory address of the data will increment by 1, and then we need to add R1 with 20. So for example, the 41 will add with 20 and it will become 61. Why we add 20 is because 41, 42, 43, all of these represent alphabetical characters in uppercase, and if we want to change it to lowercase in ASCII characters, we can plus 20. And then we store the value that we get just now, which is 21, to R2. And then inside the R2, which means inside this address, and then R2 will increment by 1. So this address will increment by 1, where it will become 1000 to FFF. And then add R3 equals to 1. So we need to add R3 by 1, and then we need to compare and see if R3 is equals to 26. Why 26 is because there's 26 alphabetical characters. So if and then we need to go to next step, which is branch if not equal to. So if the counter is not equals to 26, it will go back to L1 and repeat the process until R3 becomes 26. And once R3 becomes 26, then it will end the program.
Hi, my name is Nomelina with the matrix DE220157, and I'm going to show to you how this coding works successfully using my microvision. So first of all, this is the coding that has been created. So first of all, we need to build and then debug it. This build is to see there is no error and there is no warning. After that, we are going to store the bugging session. So this is show this assembly, which show instruction that has been created from our coding, and this is the memory that will be stored the data from uppercase that has been transferred from uppercase to lowercase. This is the register that we are going to use. So first of all, we are going to run and then run line by line. So this is the address that we are going to store our data, first data, and this is the content that has been stored in that register R0. And then this will be our data that we're going to store into R2. R3 is our loop counter. So first data is 61, and that is going to be stored in 1000 to FFE. After it's successfully stored in that register at that address, the loop counter will be counted as 1. So the second data has been stored in the memory, and then the counter will be counted as 2. So we are going to run until 26 iteration. So it has been 26 iteration maintaining loop counter. So the loop counter will be 1A. The last address is 3018, and the last data that has been stored is 7A. So this is show that the coding works successfully, and the memory and the data has been transferred successfully into the memory. The result analysis implementation, this show the successfully execution from assembly coding and to converting the uppercase to the lowercase and storing them in memory. So as we can see, the first data address, which is 2FFE, show the sequence, and then incrementing up to last address, which is 7A, with using first data is 61. Also, the data that has been transformed with a correct sequence, and the register from R0 to R3 works perfectly from debugging and then the looping until the 26 time, and then it show the work process from convert from the character from uppercase to lowercase correctly. So as for discussion, we can see that this software microvision tool and ARM that using ARM assembly language is a great tool for efficient memory manipulation and data processing. It provides accurate hardware control, which makes it good for low-level operations, and it is very crucial for resource optimization. So this show how can we manage memory using techniques that include accurate addressing and maintaining data integrity. So despite errors when debugging and build, it shows how coding gives instruction correctly and accurately so that it comes out the correct data to store in the memory. That's it for me.
I am Logan, matrix number CE220103, and my part for the presentation is conclusions. For the conclusion, a structured loop in assembly effectively transfer data from program memory to SRAM. The program transfers 26 English capital letters starting at memory location 0 times 1000 FFF capital F. Proper memory allocation and addressing mechanism ensure reliable data transmission. Assembly's addressing modes are vital for efficient memory access and modification. The loop uses instructions like LDRB and STRB to load and store data. Termination conditions and address increments ensure correct looping for all 26 letters. Assembly programming provides precise hardware control, optimizing memory use and performance. This approach is crucial for resource-constrained systems like as embedded devices. The study highlights assembly's value in solving low-level system challenges. In summary, this study shows that data may be efficiently transferred from program memory to SRAM using a well-structured assembly program that make use of loop and carefully memory management. The program success depends on the careful planning of memory location, the intelligent application of addressing protocols, and the strong loop architecture. This method demonstrates how assembly program language can be used to solve low-level system problems and offers insightful information for creating dependable, effective embedded system programs. And that's all from me. Thank you.